Hi guys, um, my name is Ayman El Zoheri and I will go through West Point Bridge Design software. After you download your software and set up the software, you can open it. You have to choose West Point Bridge Designer 2014 for older computer. This icon will work properly for you. Once you open your software, there is a window says create a new bridge design or load a sample bridge design or load an existing bridge file. As we are starting from scratch, we will create a new bridge design. Okay. The second window, just to read the design requirement for standards, just next. Then, do you like to participating in a local bridge or something like this? No. And then you can say next. What's your deck elevation? Your deck elevation is the height or the distance between the sea level or the water level and your bridge surface. So we are going to choose it's 16 meter. 16 meter will give you a bridge span of 36 meter. Also, you can add arch, something like this, or you can keep it standard. Also, you can add intermediate support, which is called pier. If you add pier here and make the height is 16 meter, so you can put intermediate pier or intermediate support, but we will not use any intermediate support. Then you can click next. What type of concrete do you like? Medium strength concrete with 0.23 meter thickness of concrete deck. 0.23 means 23 centimeter. Also, we have high strength concrete. You can choose what you want for material of the concrete surface. For the bridge surface. Then you can choose the loading type. We have standard 225 kilonewton truck, 2 lanes, or 480 kilonewton permit loading centered. I think the first choice will be good. Next, we can go ahead and get standard trusses embedded in the software. What is the difference between through truss and decked truss? Actually, through truss means your truss member are above the bridge surface. The second option, deck truss, your truss member below the bridge surface. So actually, I will create my own truss, so I will choose none. Just next. If you would like to add your name as a designer, what's the project ID, and then next, I am done. Everything is here, just finish. So right now we have a bridge with a total span of 36 meter. Here is the first point of your bridge at 0, the second side at distance 36. We have also a pointer and two lines, one horizontal and one vertical, to make alignment with the joints. First of all, let me say something. Actually, your truss, the total truss length is 36 meter. We will divide it to 9 spans. Each span is 4 meter. As you see here, this span is 4 meter. This one is also 4 meter, and the total span is 36 meters. The height of the truss is 6 meter. Let me explain something. You can make model to your truss by scaling it. So we can assume each meter is equivalent to, in the real life, is equivalent to 1 inch in your lab. So you can model a real truss to a model in your lab. So if we have 36-meter bridge or truss, it's equivalent to 36 inch as a model. And your height in the real life, it's 6 meter. So in your lab will be 6 inch. So based in this scale, you can build a real bridge in your software and make or create a model in your lab to be in the same behavior. So right now we are going to create this truss as a bridge as a first example. One more thing, for any truss we have two main elements. The first element is these nodes, what's called joint. We need to create joint first. Then we need to create members. This line called member. In the real life, this line, it's not a line, it's a real member. Your real member sometimes looks like pipe, like this, solid pipe. This cross section is solid, or it's sometimes hollow pipe, like this. You can choose what you want. Okay, so first step, we are going to create our joint, then create our members. After you open your software, first we need to create our joint. Here is the tools that you will use to create your elements. Joint, element, or you can erase what you draw. So first, create joint. At the first location, at height equals 6, notice your horizontal line at 6 meter. Just click, I create the first node. The second one, keep going to create all of your joints. Just come to the location and make click, left click. Once you are done, I don't need to draw the lower joint because they already attached to the bridge deck. To create your member, just come here and select the member tool, and then from this node to this node, from this one, right now I'm drawing the vertical. But before doing this, once you choose your member, you can choose the material of your member. You can choose what type of cross-section, solid cross-section or hollow, as I mentioned. And you can also choose what is the dimension of your cross-section of this member. The diameter, the inner diameter, outside diameter, something like this. Okay, so once you grab member tool to draw your member, just click here, keep click, and one here. So both click and keep pushing your left click until the second joint, and then release your click. Keep going, draw your members, all of them. You can start with vertical, with horizontal, or all of them at the same time. It doesn't matter, because all of them, we are going to assume all of them have the same cross section. So it doesn't matter which member you started with. These members at the top called top chord, and this member at the bottom called bottom chord, and the vertical and horizontal and inclined member called web of your truss. So the second, yes, this member are inclined in this direction. And this one at the intermediate span will be cross like this. I am done. Here is your truss. To escape, you can select this arrow. So I'm done. I draw my truss. I create my bridge. You can check this bridge safety using the selected truck at the beginning. So, but before this, the cost of your bridge right now is $389. I believe it's cheap. Anyway, so just click this icon, run the load test animation. There is the deformed shape due to the given the on weight of the truss. Wow. Once your truck moved from this side to this side, that means your truss is stable, your bridge is stable and safe. So remember, for any structure, we need it to be safe, economic, and has a good shape to be attractive for any people. Okay? If you would like to go back to your original truss, you can just hit this icon, show the drawing board view to go back to your truss.